Dear students, we are back to the class of geometric design and we are going to discuss the side distance requirements in this particular interaction also. If we try to look back what we have discussed in the previous interaction, we have very focusedly discussed about the overtaking side distance. And while discussing about the overtaking side distance, we talked about the various interactions of the vehicles within a lane and from the opposite lane, and we calculated the OSD value on the basis of the approach being given by Indian Road Congress. Towards the end of that interaction, we talked about the overtaking zone and we also looked at how we can calculate the values and we can design that overtaking zone once we have a OSD value in hand. In today's interaction, we are going to talk about the various aspects and let us see that how we can discuss about all of those in this particular interaction. It starts with an alternate approach to calculate the OSD, and then we are going to talk about the side distances under different conditions like intermediate, on multi-lane highways, on horizontal curves, on vertical curves, and also at an intersection. And there what type of intersections are there we are going to look at and we will see the side distances. Let us talk about the alternate approach for OSD first of all. Now, what this particular approach is trying to look at is, it is trying to talk about OMT, that is the overtaking maneuver time, and this overtaking maneuver time it discusses with respect to the location A2, A3 instead of A1 and A3 which was there in the case of IRC. Now, this overtaking maneuver time for a movement of A2 to A3 is going to be dependent on the acceleration with which the vehicle is going to accelerate from a speed of Vb to Vd, and that is what is being talked here in this diagram as an acceleration phase. So, based on this particular movement, we are going to calculate this OMT, and in this particular OMT, what is the distance which is moved by a vehicle from C1 to C2 is what we are going to talk. So, here we will not do 2/3 of OMT, because in that previous one approach we were looking OMT from A1 to A3 and we said the A2 and A3 is 2/3 of the OMT, and the same was calculated for the vehicles which are coming from the opposite direction. So, that is a change which is there. So, what we need is an rate of acceleration of a vehicle. We will have Vb which is 16 kilometers per hour lower than Vd. So, now we are going to look at how the values are being calculated. So, first one is that the distance travelled by overtaking vehicle while following the lead vehicle, and this will happen at a speed of Vb. So, this is nothing but 0.278 into design speed minus 16, this design speed minus 16 is Vb multiplied by time to follow, and that is t seconds, and this t seconds is usually taken as 2 seconds if it has not been given to you separately, then this is the value which we can consider. Then time for overtaking vehicle to accelerate, overtake and come back to the lane. Now, here we have to find out this time, and how we are calculating this time, which is given as t is equals to 4 as divided by a and under root of that, where a is the maximum acceleration in meter per second square at a design speed. We are going to move at particular speed here. So, how this value is being calculated? So, the distance which is there, which is nothing but d2, this is b plus 2s, and if we use the equations of motion, then it is ut plus half a t square. Say here if I consider this t as capital T, because we are talking about a time in which this movement is happening. So, this distance travelled is ut plus half a t square, and if we correlate this, then the b distance is nothing, b distance is basically the Vb into t, where this u is going to be nothing Vb. So, if we go with this analogy, then your half a t square is equals to 2s, and that gives you t is equals to 4 as divided by a and under root of that. So, what you need is the value of a, and what you need is the value of s, and this value of s is 0.7 times of the speed plus 6, where here the speed is Vb. So, it is Vb is written as design speed minus 16, and we are considering that all of these values are in kilometers per hour, and that is the why factor 0.278 is being taken. Okay, so, what we have is a distance travelled by the overtaking vehicle during time t will be b is equals to 0.278 into design speed minus 16 into t, and now we have all the three values available with us. So, we are considering all these, then what we get is the total OSD on a 2-lane carriageway is a summation of d1 plus d2 plus d3, where d2 is b plus 2s. So, 0.278 into design speed minus 16 into t plus 0.278 into design speed minus 16 into capital T, which is 4s divided by a and under root, plus 2s, which is 2 into 0.7 times 0.278 into design speed minus 16 plus 6. So, that is the value of 2s, and the value for the vehicle which is coming from the opposite direction 0.278 into design speed into capital T, again which is like this. But if you are talking about a divided carriageway, then the last component will not be there, and that is what is being written here. As I said, in these computations, whatever the formula has been given here, the design speed is being calculated in kilometers per hour, not in meter per second. So, we have an example here. We have traffic which is moving in both directions, 2-lane road, design speed 65 kilometers per hour, and the maximum acceleration rate at this is 0.85 meter per second square. We have to calculate the OSD. Now, when the traffic is moving in both the directions, it is combination of d1, d2, d3. Let us look at it. The very first thing which is being calculated, the spacing as 0.7 times of 0.278 into 65 minus 16 plus 6. So, we get 17.48 for a design speed of 65 kilometer per hour. Time to overtake t, when s is available and a is given, we calculated. So, it comes out to be 9.07 seconds. Distance being travelled in 9.07 seconds at a speed Vb is what b, and that comes out to be 148.77 meters. So, we are calculating using the same formula, and d1 is the distance which is being travelled with the speed Vb during the time to follow, and time to follow is 2 seconds. So, it is 0.278 into 65 minus 16 into t. So, that comes out to be 27.24, and the d3 is the movement at a design speed, but during the time capital T. So, capital T was 9.07. So, 163.89 is the distance which is being travelled by the vehicle coming from the opposite direction. So, what is going to be the OSD here? The d1 which is 27.24, b which is 148.77, 2 times of s, where s was calculated at 17.48, and d3 163.89. So, finally, this is the distance which needs to be there, roughly 375 meters as OSD for this 2-lane 2-way road for a speed of 65 kilometer per hour. Now, let us look at the intermediate side distance, and we talked about intermediate side distance a bit when we talked about the SSD as well as OSD. What we have discussed there is that if we are not in a position to provide OSD, then at least ISD has to be provided. The intermediate side distance has to be provided. But then what is this intermediate side distance? As far as calculation is concerned, it is considered as twice of the SSD. So, this is the value which should be there if OSD is not there at least. But of course, we discussed about in the previous interaction that if you are going to provide ISD, then the speed limits has to be provided, and these speed limits will be intimated to the drivers by way of the speed limit signs. So, this is another important thing which will be there. When you talk about the multi-lane roads, in the case of multi-lane roads, the minimum side distance that should be ahead available is SSD. That is the minimum value which has to be there. But what we discussed was that it is preferable to provide 2 times of SSD, because we have again discussed about this reasoning that there may be vehicle which has stopped ahead, and the vehicle which is coming with a faster speed is trying to apprehend that what has happened to that vehicle, whether it is going to move or it is going to be there, and at that speed, because of the perceptions which are going to be there, it is always advisable to provide additional safety, and that is the reason why we are going for 2 times of SSD in those conditions. OSD is not provided on the multi-lane highways when they are the divided carriageways. Longitudinal gradient will affect the SSD on either side of the median in the case of multi-lane road. Again, we did a numerical on that also when we discussed about the SSD, but longitudinal gradient is not going to affect the OSD on a multi-lane roads. So, these are few points which I am again reiterating, which otherwise have been discussed in the previous interactions. Now, let us look at some other conditions which can be there. So, we have a horizontal curve, and on this horizontal curve the vehicle is moving on an inner lane. So, this is a 2-lane system. So, we will have a vehicle in the outer lane moving like this. This vehicle is trying to see what is there ahead. So, this is a case, and therefore, this is the line of sight of the driver. So, this line of sight is there, and if this line of sight is being obstructed, then the driver of this vehicle will not be able to see what has happened ahead on this distance. Therefore, all of these obstructions should be clear of the line of sight, and we should have a clear vision in this particular area. That is what we are going to discuss. We will also be going to discuss of a movement where there is a curvature and the vehicle moves on this curvature, and if the line of sight is being talked, then this line of sight is going to be obstructed because of the curvature of earth, and that is one another thing we will be looking at. Another important thing is an intersection where so many vehicles are going to be there. So, if there is a vehicle which is coming from a particular direction, so we have to see that what is the direction in which probably the vehicle is moving and where is the point of conflict of that. With respect to is these two vehicles should be able to see each other, or the vehicle which is, if there is a vehicle which is going in this direction, then this is another line of sight. So, if we are talking about these line of sight, then they should be clear of any obstruction here. So, these are the things we are going to talk further. Let us first of all look at the distance at an horizontal curve. Now, when we are talking about an horizontal curve, there can be two conditions. We may be interested to provide a minimum SSD, but we may also like to provide OSD. So, it all depends what are the conditions we are going to satisfy on that particular alignment. So, we have a vehicle here, and there is another vehicle which is moving in this direction on this side. So, the line of sight, as you can see, is being defined by this line. So, this should be a clear zone and the obstruction is away from it, and we are interested to see that if this is the center line of the road, as you can see, this is again a 2-lane system. So, from this center line of a road at the center of this curve, what is this distance which should be there, which is clear of any obstruction, is a setback distance we are interested to look at. So, this distance is setback distance, and we are going to calculate this. So, this is the situation we are talking here, and that is what is being written on the other side in terms of text. The same is being iterated here, and what you can see is the distance which is visible along the center line of the inner lane should be equal to the minimum SSD at a design speed. So, if it is 100 kilometers per hour, the minimum 180 meters should be there. If you are talking about the OSD which is to be provided, then 640 meters should be there. Then the distance of the center line of the carriageway and the line of sight which is joining the end points of the sight distance. That means, when we say the minimum sight distance should be available as SSD, so what we are saying is that this distance which is travelled here is equal to SSD. So, that is what we are talking here, and with respect to that, if you are taking the end points of that distance of SSD and a line of sight being drawn and the distance of that with respect to the center line of the carriageway, then this is defined as a setback distance already defined in the previous slide. And we need to have a continuous visibility along the SSD, that is important. You keep moving along the length of the curve and you should get SSD. If still there is restriction, you need to omit those things. So, it means we need to talk about SSD and this the setback distance, and this setback distance how we are going to calculate is being shown here. Let us look at a case which is being shown where we have a road, and in this road we have again the 2-lane system. So, this is a center line. With respect to this center line, if we say that this is the center of the curve, the radius is going to be up to the center line. So, r is the radius of the curve. This is the inner lane, and the center of inner lane is being defined here, and this center of the inner lane is at a distance d from the center of the road or the carriageway. So, this is another value being shown. Then the other aspect is we have to calculate the setback distance. So, from the center of the carriageway to the line of sight which is there with respect to the point A and D, which are the ends of the SSD to be provided. With respect to that, this value BC is what we are interested to calculate. So, M is the setback distance here. So, our all obstruction should be away from there. Now, when you are talking about this and when the vehicle is moving in the inner lane, then it means the radius is going to be talked with respect to the inner lane, and the d is the distance between the inner lane center line and the center line of the carriageway. Therefore, the radius with respect to the inner lane is r minus d, and at the center of the curve, because of this SSD, the angle which is going to be caused is alpha, and because of the symmetry we have alpha by 2 and alpha by 2, and this alpha is nothing but the distance travelled is SSD with respect to the radius r minus d. So, we will have the radiance value as alpha, which is to be converted in degrees when we are going to calculate the cosines or sine values, etc. Now, let us look at the one of the case where we say the length of the curve is more than SSD. So, my length is up to this point, but my SSD is between A and D. So, SSD is AD, but length is more than that. So, when we are calculating the value of M, then this M is nothing but it is equals to BC, and I can write this BC with respect to the center of the curve as OC minus OB. So, I am talking about this distance and I am talking about this to this. When I look OC, OC is nothing but it is with respect to the center line of the carriageway, and therefore, it is equivalent to R. So, OC is R here. When you are looking at the movement in the inner lane and with respect to center line, then what is happening is that we are talking about this point A up to which we are going to move. So, considering the triangle OAB, if we consider, then OA is R minus D, and this angle AOB is equals to alpha by 2. So, if we are considering this, we have to calculate OB, then OB is nothing but OA cos alpha by 2, and therefore, it is R minus D into cos alpha by 2, and together it becomes R minus D into cos of alpha by 2 as a setback distance for this case of a 2-lane 2-way road with the length more than SSD. Let us look at another case where the length is less than SSD. So, I have a length from here to here, that is say from A to, if I give a name here as D. So, my length is now related to AD instead of SSD, but SSD is going up to say here it is P, and I can probably write here as say X. So, my SSD is going from P to X. So, in this case, how we are going to calculate the value of M? This value of M again remain related to the line of sight. So, we are calculating this because SSD has to be provided. So, we are interested to look between the movement from P to X, and therefore, the M is going to be equals to CD, and this CD can also be written as BC plus BD. This can be one way of writing it, or this CD can also be OC minus OD, that can also be condition. Okay, I can write CD as OC minus OD. So, we are going to look at all of these things. Now, when we are looking at this BC, so BC is being defined now as again OC, which is with respect to the center line of the carriageway, and OB, which is with respect to the length of the curve. So, in this case, what it comes out to be R minus R cos of alpha by 2. But when we are looking at this BD distance, so this distance is now calculated. Now, this can translate towards here. So, what we are looking at a triangle APQ and its equivalence with a triangle OAB. So, that equivalence is being looked, and when we look at this equivalence, then BD is equals to AQ, and AQ in terms of this triangle APQ can be nothing but AP into sine of alpha by 2. So, when it is AP into sine of alpha by 2, that is what it is written. Now, AP is what? AP is the total distance which is we are travelling up to P is SSD, but up to A the distance is LC, and this is happening on both the sides. So, it means this is SSD minus LC divided by 2 is AP. So, that is SSD minus LC by 2 as AP is being written here multiplied by sine of alpha by 2, and finally, what we get is m is equals to r minus r cos alpha by 2 plus half of SSD minus LC into sine of alpha by 2, where alpha is going to be calculated as LC divided by r. Here r minus 2 will not be there because we are considering that here, and this is a case of a single lane condition. But as soon as you move to the multi lane condition, then in that case what will happen is that this alpha is going to change, and accordingly the changes will come in the multi lane condition in terms of r minus d as well as alpha, where alpha is LC divided by r minus d radians, which finally is going to be converted into degree to use here in terms of cosines and sines. So, here this in the case of multi lane system, then m is going to be r minus d into cos of alpha by 2 plus half of SSD minus LC into sine of alpha by 2, where alpha is LC divided by r minus d. So, let us look at an example here. Now, in this example we have a 4 lane undivided carriageway, traffic is moving at a speed of 100 kilometers per hour. The perception reaction time is given as 2.5 seconds. If you remember, we talked about it in SSD. The distance between the center line of the alignment and the center line of the inner lane is given as 5.25 meters, that is a small d is given to us. So, this is a small t, this is capital V. Radius of the curve is 200 meters. So, r is given here. Calculate the setback distance required to have a clear line of sight to provide SSD if the length of horizontal curve is 200 meters or it is 150 meters. So, LC 2 conditions are being given to us. Consider f as 0.35. Now, when we are talking about LC, we are considering whether LC is greater than SSD or LC is less than SSD. These two conditions we are talking. That means SSD has to be calculated. Now, we calculate SSD, then it is nothing but perception distance plus the braking distance. So, 0.278 into 100 into 2.5 is the distance being travelled during the perception time, reaction time, and when the reaction is being done, it is V square divided by 254 f. So, 100 square divided by 250 into 0.35. So, what we get is around 182 meters as the safe stopping sight distance. If we compare it with the LC, what we are getting is that these two cases are that in one case the LC is greater than SSD, in another case the LC is less than SSD, and these are the distances, these are the cases which we have discussed in the previous slides. So, when we talk about that your LC is greater than SSD, then the alpha is being calculated as SSD divided by r minus d, and what we get is 53.54 degrees. So, at back distance is given by r minus d into cos of alpha by 2, where alpha is known, r is known and d is known to us. So, d was 5.25, r was 200. So, we got 26.12 meter as the distance of the center line from the line of sight, so that there is no obstruction and the vehicles can move freely. When we talk about another case when the LC is less than SSD, so in this case what we are talking about is the alpha is going to be LC divided by r minus d. It is not a single lane case, it is a 2 lane case, that is why d is going to be there, and that gives us the angle as 44.13 degrees. So, the formula for finding out this setback distance here is a bigger one, where r minus d and alpha, these are the two changes which were there, and based on that what we get is 25.51 meters as the setback distance to be provided in this case. So, this is how you can calculate the setback distances and ensure the safe visibility on any horizontal curve. Now, there are few points related to this. What are these? In the case the inner side of the horizontal curve is having a cut slope, then the average height of the line of sight above the ground level is considered, which is considered as 0.7 meters. So, it is taken with respect to 1.2 meters and 0.15 meters of an obstruction. So, 1.35. So, average on that is 0.7 meter is the what we are being talking here. So, that means you are on this type of a system, here the road is passing, and then because of this obstruction, if the line of sight is getting a problem, so you have to cut it in this manner. So, up to a height of 0.7 meter, this material is going to be cut. Now, if we are talking about an overtaking side distance, as both values for eye level as well as obstruction is 1.2 meters, then we can consider 1.2 meters above the ground level if this is happening here. Now, these things when we are talking and when you are creating a condition as being shown here like this, then this is being defined as benching. So, bench is being created here. So, that is one thing which we are going to look at, and when you do that, the stability has to be ensured. That is an additional thing which we are looking. There may be a case where the horizontal curve and the vertical curve they are together. In such cases, then how the things have to be done. So, when we are looking at these things, there may be a possibility that though your road is like this, when the curve is going in this direction, very first thing, and if you talk about the line of sight, then this line of sight is going away in the valley side. So, that can be one problem. Another problem is that there is a vertical movement also here. So, you are going up at the same time there is a turning. So, how to coordinate these two? In such cases, the sight distance should be designed both for vertical direction along the pavement as well as horizontal direction on the inside of the curve. So, both has to be looked separately and ensured that this is available, then only the safety can be ensured at a design speed movement of the traffic if it is going to be there at that form. Let us look at another case which is related to the vertical curves. Now, in the case of vertical curves, what is going to happen, as I said, there is a curvature of earth, the vehicle is coming from this side. So, there is a line of sight here. With this respect to the line of sight, there is an object, and if you are talking about SSD, then the height of the object is going to be 0.15 meter and line of sight with respect to the driver is going to be 1.2 meter above the surface. Now, when this happens, because of this curvature, this is getting tangential here, and we are being able to see this object which is 0.15 meters high, and therefore, this distance which is going to be traveled here is an SSD to be provided. When you talk about the another case of a vertical curve where there is a valley curve or a sag curve, then the vehicle is moving on this downgrade and then it is going up. During the daytime there is not going to be any problem because all of these vehicles can see each other, but during night time we are looking at the beam through which the headlight beam is going in this form, and when we talk about the level at which this road is there, so the beam is going parallel to it and then it makes an angle beta which is usually taken as 1 degrees. So, we are trying to look the visibility up to a point at which the height of the object is equals to 0. So, any vehicle which is there, any object which is there should be away from it. So, if you are talking about this distance which is being travelled, when the height of the beam is 0.75 meter, beta is 1 degree, h2 is 0, then this distance is being defined at the distance being travelled under the headlight. So, it is headlight sight distance. So, that is how we define it. So, these are the things which have been defined in these slides. What it says is we can have two types of curves, the summit curves and the valley curves. Summit curves like this and a valley curve like this. In the case of summit curve, what is happening is the curvature of the earth is creating an obstruction. We need to ensure the height of the eye of the driver as 1.2 meters and height of the object as 0.15 meters, and if we ensure that, then whatever is the distance there, that should be minimum equals to SSD. So, that is the minimum value which has to be there. When you are talking about the valley curve during daytime, as I said, nothing an issue, everything is visible, but when you talk about the night time, then we are looking at only on a distance which is available to you in terms of an headlight distance, and this has to be calculated, but this cannot be less than SSD. This has to be minimum in all the cases, and we have to provide it in case HLSD comes less than this. So, if your HLSD is greater than SSD, then we provide HLSD. If HLSD is less than SSD, then we will provide SSD. So, it talks about the various heights, the height of beam as 0.75 meter, the angle as 1 degree, and therefore, in the case of summit curve it is equals to SSD, in the case of valley curve it is equals to HLSD with the minimum value of SSD, and all of these things we are going to take further when we will talk about the alignment in our further interactions. Now, let us come to the last thing, which is related to the intersections. We have two types of intersections: priority intersections and uncontrolled intersections. What you can see is that in this case the specification of the two crossing roads, they are same. In this case what you found is that this is wider and therefore, this is defined as a major road, this is a narrower one and being defined as a minor road. So, in the case of uncontrolled intersection, what we are saying is there are two roads which are crossing each other, which are of the same specifications, and when they are of the same specifications, we assume that the speed with which they are moving, these speeds are nothing but they are equals to the design speed only. And if they are equals to design speed, then we are interested to see that what is the distance which should be visible to the vehicles which are moving here. So, this vehicle is moving like this is moving like this is the point of conflict. So, the distance which the vehicle are moving, which is D1 and D2, these vehicles D1 and D2, they should be equals to minimum SSD. That is what we are trying to ensure on these uncontrolled intersections. When you are talking about the priority intersection where a major road is being met with a minor road and it is crossing also, we are looking at the vehicle which is coming here and there is a vehicle which is moving on a major road. Obviously, this vehicle will be moving at a design speed which is quite higher than the speed of this vehicle of minor one, which is going to be quite less in this case with respect to the design speed of the vehicle which is there on the major road. So, we are trying to see the visibility. Now, this visibility is again being termed with respect to the point of conflict. What it says is the minimum distance of 15 meters should be there as a visibility on the minor road, but on the major road this distance which is going to be there from here to here, that should be equals to the distance being travelled in 8 seconds at a design speed. Now, why 8 seconds? This 8 seconds is being considered that this vehicle on the minor road comes and stop here on a stop line. So, I may have a stop line here, then it looks that whether there is a vehicle on the major road and there is a gap, then this vehicle can cross and it will come to this location. So, it will start, it will accelerate, it will cross the width of this major road and this whole takes 8 seconds, and therefore, the safety margin which should be there to this particular vehicle on a minor road should be equivalent to the distance travelled in 8 seconds on a major road. And that is what gives us that if we have this A, B and C, then this is the site triangle in the case of priority intersection. Here this is A, B and C, this is another site triangle in the case of uncontrolled intersections. The same things have been defined here, defining the priority intersections and the uncontrolled intersections. Uncontrolled, both crossing roads having same specifications, minimum SSD has to be there. This creates a site triangle as I have shown you as A, B and C, and this should be clear of all obstructions. In the case of priority intersections, there is a major and a minor road. Traffic on major road is expected to, minor road is expected to stop, examine the gap, accelerate and cross. So, this is taking, as I said, 8 seconds, and in this 8 seconds the vehicle on the major road is going to move, but it distance which is going to be travelled in this 8 seconds cannot be less than SSD. So, we have to calculate these two things, and minimum distance on the minor road is taken as 15 meters. But there are going to be some cases where these things are not available and the obstructions are there, and when these obstructions are there, then what we can do is we have to see that whether we can restrict the speed on any of particular road, and when we restrict the speed, then in that case we can have a lower side distances. So, we need to adjust the speed with respect to the available distances, and accordingly we have to find out what is the speed limit, and those boards have to be provided, and this can be done on either of the road or on both of the roads, and that is what I am going to just talk here. So, what we are saying is that this was the line of sight here, but there is an obstruction which is like this. That means now the line of sight is being obstructed. So, if I talk about this, then what can happen is that my line of sight is going to be in this form. So, if I maintain a distance d2 on this direction, my new distance is going to be this much, which is d1 dash, which is less than d1. And if we are talking about this, then for this d1, if it is v d1, now what we are going to get is v d1 dash, which is less than v d1. So, we have to impose this speed limit here. So, depending on the type of traffic which is there, we can impose a limit on one of the side, or there may be a possibility if this has been a restriction in the as an obstruction to the line of sight. What I do is that I create a line which is parallel to the initial line of sight, and therefore, I get two new locations and my distances are going to be this one. So, this is d2 dash and this is d1 dash. In both of the cases, now I am going to place a sign here as well as a sign here, which defines that the speed limits are being imposed. So, this is how we can calculate the sight distances under different conditions or as well as at an intersection. With this, we come to an end of our module 1, where we have discussed the various types of sight distances under different conditions in which the traffic is being operated on a road or a carriageway. With the completion of this, now we are going to move to the next module, and this module is related to cross sectional elements, and we are going to start with that in the next interaction. Till then, thank you and bye.